pair of formulas that we have the distance formula. Distance equals the big square root. x2 minus x1 squared plus y2 minus y1 squared. This is when you use your distance formula. Distance formula tells you how long sides are.
I'm so good.
Okay, take them out.
I don't know this.
So if you want to know if sides are congruent or diagonals are congruent, this talks about length. Okay. Our midpoint formula, I don't think we've seen this in a long time. X1 plus x2 over 2, comma, y1 plus y2 over 2. Remember, you don't ever add these two together. A midpoint formula is like two things. It's like a point, like x, y. Okay? We use it to figure out if we have a midpoint, obviously. And that also means that if our diagonals bisect each other. Because if they bisect each other, they should meet at that midpoint. Okay? And then lastly, we have our slope formula. Y2 minus y1 over x2 minus x1. And slope we use to decide if things are parallel and perpendicular. Okay? So if opposite sides are parallel, if our diagonals are perpendicular, or sides are perpendicular. Okay. Do all of those formulas look familiar? Okay. Let's jump down to this dude. So I think that's a whole page we skipped.
Holy crap, yeah.
Alright. So it says we gotta classify the triangle, so we gotta figure out is it scalene, isosceles, or equilateral. First off, that's how many sides are congruent, right? So how many sides are congruent in a scalene triangle? None, or like one, I guess. Isosceles is 2, equilateral, all 3. Okay? So if I'm trying to find out if sides are the same, should I use my distance formula, my midpoint, or my slope?
Distance.
Distance, that's going to tell me length. Okay? First thing, let's find the points of these. A is at 0, 1. B is 4, 4.
C is 7,
7, 0. Alright. So we're going to use the distance formula, guess how many times?
3 times.
3 times for the 3 sides. Let's do AB first. I know, you. Let's do AB. All you're doing, first off, what are my x values in AB? 0 and 4. These are my x's. 0 and 4. We're going to subtract them. When you do your distance, it doesn't matter which one you put first. So I just always like to put like the bigger number first, or what's going to make it positive. Okay, and then square it. Add the y's. The y's are 4 and 1. So 4 minus 1 squared. So when I simplify this, 4 minus 0 is 4. I'm just going to do one where I run it all up, okay? So I got 4 squared plus 4 minus 1 is 3. So I got 3 squared. 4 squared is 16. 3 squared is, when I add them together, I get, so how big is AB? 5. Okay. Let's do BC now. What are the x values of BC?
4 and 7.
4 and 7. So I'm going to go 7 minus 4 squared. 4 minus 0. Yep, again, doesn't matter which order you do them in because you square them anyway. Alright. So what is 7 minus 4? And then what is 3 squared? 9. 4 minus 0 is 4 squared. 4 squared is 5.
No, it's time of the
16.
16. So we're at the same place. Square root of 25. BC is 5. So do I have to check that last side? Yeah, because I've got to figure out, right now I have 2 that are the same. So I got to figure out if it's going to be 2 are the same or all 3. So the last one we're going to check is A to C. X values are 7 and 0. Y values are 0 and 1. We love zeros. Zeros are my favorite. 7 minus 0 is 7. 7 squared is 1 minus 0 is 1. 1 squared is. So this gives me square root of 50. To be honest, you don't have to solve for like what this is, because the only thing we care about is it the same as these? And is it? No. So we know what kind of triangle, scalene, isosceles, or equilateral. Isosceles, because there's 2 that are the same. Okay. And then if you scroll down, or on your bottom half of the page, I'll scroll. It asks, is it a right triangle?
No. Yes.
Okay.
No. No.
Well, you can't just say it. No, you can't just say it. All right. Here's how we determine if it's a right triangle. Well, first off, how do you know if it's a right triangle or not?
It's a 90. It looks like a right triangle.
I don't care about what it looks like.
90 degree.
Yeah, if there's a 90-degree angle in there. Okay. Here's where we save some time. Does angle A look like it would be 90?
No.
No. Does angle C look like it would be 90? No.
Mm-hmm.
You do have to test 1, so you get to cross off 2 automatically. So we're going to see if this angle B is a right angle. Okay? To do that, so to determine if I have a right angle, am I going to use the distance formula? No. Am I going to use midpoint? No. What's left to use? Slope. And if I have a right angle, what do I know about those slopes? Are they going to be parallel or perpendicular? Perpendicular, which means are the slopes the same or are they opposite reciprocals? Opposite reciprocals. Okay. So, when we look at our slopes, we're going to look at AB and BC because that's what makes up that angle B, right? Yeah. Okay, so let's, I don't know how far I can go down. Like there. Okay, let's look at AB first. If I look at the slope for AB, slope is y minus y over x minus x. Okay, so the y's are on top. So what are my y's of AB? 4 and 1, good. So I'm going to go 4 minus 1. Slope is the only one where you have to have it in a certain order. So now that I put this 4 first, this 4 has to go first on the bottom. Okay? So I get 4 minus that 0. So on top I get 3, on bottom I get 4. So my slope of AB is 3/4. Okay. Now I gotta find the slope of BC. Y's on top. So you want to do 4 minus 0 or 0 minus 4? 4 minus 0, okay. 4 minus 0. And then what has to match that 4 minus 0? 4 minus 7. What do I get on top? What do I get on bottom? Which makes the whole thing negative. Are these opposite reciprocals?
Yes.
Yes.
So do I have a right triangle?
Yes.
Yes. questions there. What? That's one problem. I told you we'd do like 3.
Do you have any extra calculus?
No. I love how you thought now would be a good time to ask that. Let's do this one.
That's a squid.
Actually, go back to this one. We're just gonna write something real quick on there. So it only sounds like a half problem. I know. If I wanted to know, is it a parallelogram? What does it mean to be a parallelogram? Like, what do I know about parallelograms?
The opposite sides of it.
The opposite sides are parallel. So how would I go through and prove that's parallelogram if I want to know that opposite sides are parallel? I would use slope. And how many times would I use it? Twice? 4 times, yeah. I would hope that when I want these slopes to be the same or opposite reciprocals.
Same.
The same.
Those
So I'd want those to be, we'll just do it. How about that? When you have a graph, you can count slope with rise over run.
You go up 1 over 3
So we go up 1 over 3. So this is 1/3. What's this slope?
Up 1
Yeah, up 1 over 3. Yeah. So are those parallel? Yeah. And then I want these to be parallel. So I go up 1, 2, 3, 4, 5. 1, 2, 3, 4. So negative 5/4.
And then that one's also.
Is it, or did you just watch me? You counted it?
I can't.
It is. Negative 5/4.
Yeah, see?
So can we say it's parallelogram?
Yes.
Yes.
Tell me down.
But isn't it a rhombus anyways?
We're not even looking at the rhombus yet.
That's the thing. Look at it closely. That's not a rectangle.
One more problem.
We never said it was a
We
rectangle.
want it to be a parallelogram, so
It's still parallel.
okay. Alright, one more, because you insist. Alright, what do I know about rhombuses?
They're all parallel.
Ones in the middle are 90 degrees.
The ones in the middle make 90. Up. What
Four
else?
sides.
All sides are the same. What else?
4 sides.
He's not
Yeah.
wrong.
No, you're not wrong. No. Okay. Is having all 4 sides the same specific to just rhombuses?
Absolutely not.
Are you talking about squares?
Yeah.
Sure.
Well, what other shape has all 4 sides the same side square? Besides a square.
Rhombus.
A rectangle?
I don't know. I'm just throwing out shit.
We just-
Okay.
It's okay.
circle.
A circle, yes.
There's a circle on
I'm
the
just
side.
throwing
Are
out
you
shit.
stupid?
Stop. Don't be rude.
It said circle.
It
There's no
was a
sides
joke.
on a circle.
Okay, so something that's specific to rhombuses is that they do have 4 congruent sides, okay? Yes, that also applies to squares, but what else do squares have that's special about them?
They're
The
the
right
only-
angle.
Right angles.
They're right angles. Yeah, so if you're trying to prove a square, you have to prove all the sides the same and that you have right angles.
Oh, that's so hard.
Exactly, that's why we should have a rhombus, okay? So we're just going to try to prove that all these sides are the same.
So we have to do the distance formula 4 times.
Oh! Yes,
I'm so smart.
you are so smart. The smartest.
Oh.
What do you want to start with? Oh, we should label these first. A is at where?
Is that -2, -3?
I was thinking
What?
-3, -4.
Oh, shoot.
-3, -4.
Wait. Oh, wait. Okay. Just. I'm fine.
B is way up at 5'2".
I really can't tell where the middle of this is.
C is at
-2.
-2, 3.
3. Holy crap.
And D is at 4, negative 5.
I need to make the axis lines darker. That's why I got them mixed up. I see where it is now. I see where it is.
Which one do you want to start with? Which line?
The one on the left.
AC. Okay. What do I do? How do I find distance?
I know.
Go Bryson. Plug it in. Start with x's. Our x is -2 minus -3 squared plus my y's.
Negative 4 plus 3.
Well, -4 minus 3.
Yes. Minus.
Minus. It's always a minus.
Except that one will turn into a plus because you subtract.
That's what I'm going to turn into a plus. What is -2 plus 3? 1. What's 1 squared? Sorry, Bryson. It's okay. -4 minus 3 is? Negative what?
7.
-7. What's -7 squared?
49.
49. Positive 49. So this is the square root of 50.
Did that? Who does it?
It does. So let's just leave it at square root of 50.
Alright.
Which one do you want to check next?
That's CB.
So this one's good. Okay, let's check CB. CB.
This is a lot of
That is a lot of work. Give me my x's.
-2 and 5.
-2 minus 5 squared plus 3 minus 2 squared. -2 minus 5 is? -7 squared is? 3 minus 2 squared.
It's 50 again.
Only 2 more.
They're both 50.
You want to see shortcut?
Yeah.
You guys probably don't remember, but when we talked about Pythagorean theorem, I told you that it was like a disguised distance formula.
Let's do the Pythagorean theorem instead of the other two sides.
So if I take this little triangle where BD is my hypotenuse and here's my right angle.
Yep.
Yeah?
Yeah.
Everybody see that triangle?
Why are they staring at me?
Big.
I don't know. Just ignore them. They ignore me, so. How long is this side? 1.
Seriously?
How long is this side?
A lot.
How long is it?
5.
Hey, stop.
2, 3, 4, 5, 6.
Hold on. 1, 2, 3, 4, 5, 6, 7, right?
7.
Isn't that what we keep getting here?
Yeah.
You have the square root of 1. Oops, I didn't mean to put squared. Well, yeah, 1 squared plus 7 squared. So is that, am I going to get the square root of 50? Yeah. We did the Pythagorean theorem. That's okay. We're going to do it again.
Oh, I see.
50.
They were staring at me.
Last one, AD. Draw your little triangle. This is 1. This is 1, 2, 3, 4, 5, 6, 7.
Oh my gosh, it's a rhombus.
Square root of 1 squared plus 7 squared.
It's a rhombus.
It is a
They
rhombus.
sell pizza.
Promise, guys.
The
Yeah,
Rhombus
really
guys should sell
scouting.
Rhombus pizzas.
I know, right?
It's because no one likes math. That's what it is.
Rhombus pizzas would sell so well.
Dude, I would buy that.